Okay, good morning, everybody. Welcome to this webinar from UVexplorer and PRTG about how to supervise your OT networks better. My name is David Montoya. I work with Paisler PRTG, and today I am co-hosting this webinar with a couple of very good professionals here, Mr. Paul Katzoff and Brian Kapp. Good morning, Paul.
Morning, David.
Hello.
And morning, Brian.
Hello.
So today we would like to talk about some things related about a couple of products that work together to provide visualization of the OT networks. So perhaps, Paul, you want to talk a little bit about what you guys do at UV Networks with UVexplorer?
Absolutely. My name is Paul Katzoff. I'm the VP of Sales here at UV Networks. We're joined today with Brian Kapp. He's one of our product specialists. And just a little background on UV Networks. We provide layer 2 network mapping. And today we're going to display how we integrate with PRTG on OT networks and display how that integration will benefit all these operational technology firms out there.
Thank you very much. So let me go for the agenda for today. We're going to talk a little bit about IT and OT convergence, basically because we've seen that there is a lot of people from the OT networks, ICS kind of side of the networks, right? But there's also a lot of people joining from IT. So we're going to go through a tiny presentation about IT and OT convergence, why are OT networks different, right? We're going to go through what's PRTG and UVexplorer, a couple of demos, and then we'll have some time for questions and answers. So before we get started, just make sure to know that within Zoom, you have a Q&A section where you can just type your question at any time where you have it, and we are going to have this Q&A section at the end of the webinar. So just make sure you're using the Q&A section and not the chat, because if you use the chat, we will lose track of that when we finish the webinar, right? So if there's any missing question to get an answer, we won't be able to know that. So please help us out and use the Q&A one. And let's get started with this. So IT and OT convergence, right? It's pretty much known as industrial automation for a long time, but nowadays you can listen to this IT and OT convergence thing, which basically means how have we changed the way that we manufacture things, from having multiple people, and this is the same factory, but nearly 80 years later, right, where you had a bunch of different people doing manual work to get something, in this case apples, to get boxed and packaged and shipped. And how is it now? So of course we are all very aware about the number of different technologies that nowadays are present in a shop floor, and how this makes it more complex, right, to manage everything. So we're not talking only about the proper industrial automation machines, we're also talking about connectivity, and maybe we are talking about servers, and maybe we're talking about applications which are not necessarily on the PLC level or the control level, but they are in an IT network, and they are interacting with each other in order to make all these processes fully work, right? So understanding this complexity, we see that nowadays there are so many different technologies that people need to keep a hold on, right? And these are related to building technologies, right? This might be temperatures or environmental conditions in a certain factory or a certain building, might have to do with physical security and access restrictions to certain places in a facility, right? Then we have everything related to the data center, and the data center is really related to services, both on-premise, in the cloud, right? And everything is gathered together into more and more complex data centers where a lot of technologies are interacting. And of course, we have all the control layer, right? So we have all the sensors, we have all the actuators, we have all the control with PLCs, with IPCs, with RTUs, right? And we have SCADA systems and HMIs. So the ecosystem is very broad. And what we have seen lately, coming from a company that has a lot of, we have more than 25 years of experience dealing with IT, is that IT and operations have been independent for so many years that nowadays trying to put them work together is just not as easy, right? So operations have kept the plant running, while if historically IT has managed business applications, and these two are not necessarily working together. They are not talking to each other. But nowadays, what has brought them together, both IT and operations, is mainly when you have any system failures, right? If there is downtime, if there is a problem, that's when both operations and IT people are meeting together to try to solve the issue. And of course, this is not the ideal situation for you to make friends with another department, right? So what has happened lately is all this industrial automation going to networks, right? Or going to the internet through IIoT, for instance, all the trends like, hey, you have to do decision making based on data. You need to use big data. You need to use, machine learning and predictive maintenance, right? So all these big words that we hear every day, plus the cybersecurity problems, they are pushing actually for closer interaction between these two departments and joint efforts, right? But this hasn't been easy, let's say, because there are different backgrounds and there are different objectives and different perspectives from both departments, right? There is also the problem of scalability because, yeah, maybe corporate is pushing for, you need to gather more data. Okay, which data? What do you need it for? And many people don't really have a real answer for that, right? So controls engineers are bombarded every day with, you need to get more data for us to take decisions, but they don't really get a good feeling about what sort of data. And this is creating, scalability issues because now there is data lakes out there which are not perhaps properly managed, and they don't have the right data, and they are just taking up storage, right? And this has a cost. So all the scalability is going to be eventually a problem as, the number of technology devices out there continues expanding. Then we have cybersecurity, as we said. So there have been several cases in which people went into networks through OT devices because OT devices are not meant to have a big, robust cybersecurity scheme around them, right? So, of course, this is a very big challenge, and there is a lot of people nowadays trying to figure out the best way around it. We also have the problem of having disparate systems, right? And there is lack of visibility across IT and OT. So people from IT don't get to see what's going on, what are the problems until they become a problem, right? And the same happens with people from operations relying on IT devices. And then, of course, their IT devices are probably redundant. They are probably made to avoid downtime. But on the other hand, they also have problems with traffic. They have problems with resources in these devices, right? And the systems they are using are normally blind to all of this. So for the IT people out there, we just want to make a little recap about what makes OT networks different, right? So OT is not homogeneous. The proprietary communication protocols are very vast, right? There are a lot of them. There are several which are not proprietary necessarily, but they are OT protocols. And they are very different from the IT protocols that an IT network manager knows and is used to. There is a big combination of vendors and technology from different generations, because that's another thing. Different from what happens in IT, OT devices, they are made to last. And sometimes you can be having something which was built over 35 or 40 years ago, which is perfectly working fine and it's performing every single day. But of course, 40 years ago, the notion of technology, the notion of security for technology was very different in communication as well, right? So in OT networks, you can encounter different generations of technology working together. OT devices, they are not resilient, right? So again, the same idea, error handling in these older devices was not powerful because they were not meant to really support in communicating these kind of errors as we know them today, right? They're also very tight on resources in several cases, especially when we're talking about older gear. So of course, they couldn't devote a lot of these resources for error handling. It was just, okay, quick restart and the machine is going to be working again. Nowadays, thinking about IT or from the IT perspective, this is not very, very common, and that makes it very hard for some IT network managers out there to understand what's going on with OT networks. And it makes the devices to be highly sensible, right? The other things are OT devices are not necessarily secure. So again, older devices, they don't support authentication. They don't have patching or upgrading in an easy way. So this is a bigger challenge for people when it comes to trying to create some cybersecurity perimeter, for instance, or trying to get better understanding on how can all these devices be secured. And there have been big attacks to manufacturing in the past, right? So people taking control over water treatment plants, people taking control over electricity distribution systems, and more things, which are critical, right, for the countries. The other thing which is normal in OT networks is that they are air-gapped. The majority of them, they are, right? So they don't have internet access. So how do you deal with patching and upgrading stuff if it doesn't have internet access, right? That's normally one of the main questions that IT people has. And not only that, if you want to get access to these kind of networks, you're required to have some sort of a, safe space to do that, right? So a jump host, for instance, you need to deal with firewall rules and IPS so that you can comfortably and securely access these networks without necessarily exposing them, right? The other thing is OT vendors are highly specialized. So different from, again, IT, where you have a big number of, vendors which are pretty much monopolies. Let's put it like that, right? So you have a couple of different versions of operating systems. When it comes to OT, you might be talking to people creating thermostats. You might be talking to people creating robotic arms. You might be talking to people making line counters. You might be having, all kinds of different technologies. And not all of these are interoperable because the idea is for them to perform a certain function, which of course in the bigger process can operate with each other. But when you look at the bigger picture of everything that you might have in a single shop floor, yeah, if they are not part of the same process, they probably won't be able to talk to each other. The other important thing here is there are OT vendors specifically designed or specifically designing a bunch of different devices which are for OT, right? So switches and firewalls, they would need to be able to understand industrial protocols like Ethernet IP or maybe Profinet or something like this. And IT gear probably doesn't understand these things, right? So here you're required to have specific OT vendors in your network in order to be fully functional. The other thing which is different is topologies, right? So OT networks, they need to, have close to real-time communication because in a matter of milliseconds, you probably can spoil a full process if there is not the right communication. This is not necessarily the case in IT networks. So IT networks can deliver messages and you're expecting that those messages are going to arrive at some point, right? But they are not so time critical. The other thing which is very different and that can blow IT people's minds is, the fact that there are a lot of ring structures within OT networks to support redundancy, right? Duplicated IP where you just, disconnect and connect a certain PLC or a certain device. And that's for an IT manager or network manager, that's just wrong, right? So they don't understand that OT networks require this in order to provide 100% uptime for all the processes, right? Static IPs are also very common. And, there are other different topologies which are, vary a lot compared to IT. So the main thing that we see here is OT networks are critical to production because they are an integral part of production, right? So you don't expect to find somebody from IT saying like, hey, I'm part of sales or I'm part of, I don't know, accounting or something like that. They provide a service, but they are not part of the departments themselves. OT networks are very different from that perspective. So from that perspective, they are part of production and production cannot run without them, right? It is very important also to get visibility of the status and providing crucial information to other supervision tools because there are, OT production only specific supervision tools out there like SCADA systems or HMIs. And these guys are blind to whatever is going on in the network, right? They are very focused in production. People might take control over devices. They can, have a lot of visualization. They can keep historical records, etc. But when it comes to having information on what's the underlying layer of networking, these systems have no information, right? So being able to provide with visibility is a good asset. And of course, everything related to asset discovery, because again, these networks are very broad, they are very big, and they have a lot of different devices within them. So all the asset discovery, documentation, and monitoring of these networks can support, as we were saying here, some other stuff, some of the big words out there, right? So predictive maintenance, cybersecurity, centralized data visualization for decision-making, plus other stuff which are looking more simple, but on the other hand, allows for people to focus on what's really important, right? Like alerting in the background, so that you don't need to be looking all the time at what's the current status of a certain machine, and having the possibility to keep historical data. Well, all of this can support in bridging these IT-OT convergence gaps that we are looking at every day, right? So this is where our products come together to support you in having a better visualization and better visibility of what's going on in your OT networks. So these are two products. We have UVexplorer on the left-hand side, and UVexplorer, as you will see, is a topology map, configuration backup, asset discovery, and documentation tool that will be able to check what's going on in your network and start creating the relationship between the different devices that you have. You will have different ways to do that, as Brian is going to show. And part of how do we work together is you can actually import all the information that UVexplorer is creating or gathering from the OT networks into Paceler PRTG. And Paceler PRTG is a remote monitoring historical data visualization tool that has the capability to talk to both OT and IT devices in order to provide you with, you know, a single pane of glass where you can see what's the current status of everything that you have connected to your OT and your IT networks. So with that being said, I'm going to give the microphone and the screen to Brian so he can introduce us to what UVexplorer is doing.
Okay, so thank you for having us today. And what I've shared here is our UVexplorer client or agent that is, as was described, is a discovery and asset tool that can automatically discover an IP network and provide not only asset data, but also topology relationships, and also dive deeper into the configuration management side of any IT or OT network. Some of you may be familiar with the UVexplorer functionality and some of you may not be, so we're going to do a brief walkthrough about how this works, and then also demonstrate how that plugin is connected directly to PRTG. If you're looking directly at any discovery tool, everything that we do starts specifically with credentials. We, like PRTG, utilize the SNMP protocol to discover devices on your IT network. And we support anything from SNMP v1, v2, v3, through other protocols like Telnet, SSH, and particular HTTP or REST APIs for lots of different environments like Ubiquiti, Meraki, and Ruckus, and so forth. Once you have these protocols defined, what you can do is go ahead and set up a discovery setting where you can define what part of the network you want to explore. So you start in a particular seed IP range, telling us how you want to discover, whether you want to just ping sweep or crawl around the network through an ARP cache discovery. And you can indicate what protocols you want us to test to see if those devices support those protocols. And then we will go ahead and try to discover everything that we can about those devices. You know, in the UVexplorer world, we definitely want to know as much about those devices as we can, not just an IP address, a MAC address, or a host name, but what type of device it is, what serial numbers, what software it's running, and also how it's interconnected. But with these discovery settings set up, you can go ahead and run what we consider a discover or a scan of the network. And one of the things that's unique about the UVexplorer environment is that every scan you do you can actually save it as a document or a snapshot of what the discovery was at that time. So everything that is captured during any scan can be saved in our repository that runs here on the agent, and you can keep a time capsule of how everything was at a particular time. The reason that we do this is so we can do differences between discoveries. So if you look here, I have a number of discoveries that are saved here in our lab. And what you'll see here is we've scheduled these discoveries to run every few hours so that it will capture the changes of the network. But then we also have what we call a roll-up of how all those changes kind of merge together to kind of give you the most comprehensive view of the network. But with the discovery settings in place, you're ready to start discovering the network. And what we would do is normally just go ahead and pick those settings and discover everything about the network. And we're going to go ahead and skip that for now, just so we can kind of preserve our time. But I'm going to go ahead and open up a previous discovery of our lab here. And when you when you're looking at a discovery result, what you see here is on the left, we try to break down every device that we found on the network based on its function on the network. Now, obviously, there's some generic categories like all devices, core devices, and SNMP devices, but things like routers and switches and wireless controllers, wireless APs and printers, all of these devices will UVexplorer will try to categorize so that you can view those separately and utilize them in reports and mapping. But if you drill into specific things about these devices, you can see we have a listing here to the right. Details all of the names, IP, MAC addresses, and vendors. And at the bottom, we have details about those devices. So particularly in this environment, like these switches, you have system information, IP addresses and interfaces, bridge ports, and what VLANs they're configured on. And you can see out here that the UVexplorer is already documenting what devices are connected out each individual port. So you can see here what devices are connected to each port, along with the asset and inventory for models, serial numbers, hardware versions, and then detailing all the links and credentials. Now, most people look at, excuse me. Sorry, getting a frog in my throat here. Most people use UVexplorer to not only discover the IP devices themselves, but the relationships of those devices. So you can see here that UVexplorer, through that simple scan, can automatically document how the devices are connected together. And you can double click on those devices and get all the details about them, or you can just look at them here in the map and mouse over them to show the relationships based on the connectivity of each port here on the topology map. Now, along with these maps that are auto-generated, you can do a number of different things. You can export those to a documentation tool like Lucidchart or Visio by simply clicking and generating a VDX document. We can build you a topology view of those, a topology document of those devices so you can share those with your IT organization. You can see here that all of the features or all the details of the discovery are available in the document. Not only, we don't want to just do graphics, we want to do links, VLANs, interfaces, etc. But as mentioned earlier, it's like, how does this information get directly into PRTG? So we've discovered this information here, but through the PRTG API, which you can define here as one of the credentials in the UVexplorer environment, you can just go ahead and set up your target server for PRTG with a username and pass hash. And then you can also, using this export tool, you can export everything about what we discovered to PRTG. So if I simply click on export to PRTG, Currently, I have a PRTG instance just running here with really nothing in it. So I just have my local probe with folders for network infrastructure. So I'm going to go ahead and I'm going to find a place to put these new devices. And I'm going to create a new group with just ping sensors on them. By simply hitting export, we can share all the information that we gather about these devices directly with PRTG, as if we were a native PRTG discovery agent. So if I jump back over here and refresh my view here just a little bit, you can see that I am now listing all these SNMP devices here inside of PRTG with their ping sensors. And some of these are already reporting back. The PRTG polling engine is already picking them up and reporting their status. Now, at this point, PRTG can function completely on its own. We've configured it as if it's its own product, and it can just ping these devices. One of the things that we add along with that export is if you go to the group that we just exported, you'll see two new tabs here, a UVexmap and a UVX report. If you click on the UVX map, you'll see that the topology map that was here invisible inside the UVexplorer agent is now shared with that group here in PRTG. And not only is the map there, but you can double click on the devices and get all the device details, IP addresses, interfaces, bridge ports, and their connectivity. So all of the information that we captured inside the agent is now available for your PRTG administrators to be able to view from a mapping perspective. Also from a reporting side, you can see asset and inventory of the devices, their connectivity. So if I was looking for a particular network device on the in my repository, I can simply come to this report and type in an IP address. Let's see, let's try here at 3560, and I can see how all those connections are to the CAT 3560, or if I was to export the whole repository, I would get all the end stations also. So, sorry, but then going back to our device list, any device that you click into here, you can also see the specifics about it. Like, for example, if I clicked into this 3560, I can look at the UVX details. There's all my IP addresses, bridge ports, everything, and asset and inventory. And along with that comes the ability to not only discover and map everything about these devices, but also we mentioned that one of the protocols that we support is Telnet and SSH, and also the REST APIs. As part of the discovery process, UVexplorer also offers you the opportunity to capture and back up your configurations. So you can simply, in the discovery settings, you can specify that you'd like to use these additional protocols and click on the capture device configuration side, and those configurations will automatically be captured during the discovery. So during the switches discovery here, we can see here that there's a new tab here called configs, where we're capturing the running and startup configuration. So with this feature, you can actually tell what we do is we actually capture the running config and startup config at that time and compare it to a previous capture to see if anything has changed. If it has changed, then you get multiple rows inside these environments so that you can go back and compare those. So you can go back to any kind of running config and see the differences between the devices. Like this one got a banner change. And so you'll be able to recognize the exact changes here. But those same configurations automatically get pushed to the UVX details here inside of PRTG. Those same comparisons and views are also available within the PRTG console. So UVexplorer really acts like an enhanced or a discovery agent for PRTG with some additional features to enhance the experience of both visualization and configuration management. Now, one of the things that we we're trying to identify for this webinar is that how the IT and the OT environments actually merge together. For example, in our lab here, we have a few Hirschmann here that we also can see directly in our topology map. And you can see here them, let's see, there they are on the edge of this network. And we can identify them and show you how they're interconnected, being able to provide full visibility of how the network is actually put together and how your OT environment is built. But also along with that, you can get the details of those individual devices, along with their serial numbers, model numbers, and so forth for reporting and management. But along with that, you can automatically use the tools to say, I want to capture the config from this device. So some of these devices support SSH, some of them support things like HTTP. So you can simply capture those using different protocols, and you can view that, for example, directly right there. So by simply doing that, we've captured the configuration from that Hirschmann device, and now it's part of our repository. And when we export that device information is automatically synchronized with the PRTG environment so that everything is kept up to date. One of the key aspects of the way our agent interacts with PRTG also is not only just exporting the maps and the visualization, but we also provide a number of specialized monitors, like for example, the config monitor. This config monitor allows you to come in here and say, well, I want to set up on a schedule, say every 5 minutes or every 10 minutes or every day. I want to go through a number of devices, and you can see here that we're not just including the OT environment, but also the IT infrastructure to capture the running config. And then you can, by simply doing this one monitor here, and then on the event side, you can click it so that it will actually send those configs directly to PRTG. When you do that, then it'll automatically keep these configs up to date, both in this repository, but also in the PRTG repository. So it's a very specialized monitor that gives you the config capture capability, but also a notification mechanism so that we can, when you save it and notify here, we will actually place a sensor on these devices inside of PRTG for monitoring the config. So that if the config ever changes, you will actually see an alert directly in PRTG, and it will use all the alert notification mechanisms that are available for PRTG to show you colorization, SMS messaging, emailing, and so forth, to be fully aware of any changes from the configuration side on those devices. Along with that, one of the key features I failed to mention when you're dealing with any kind of IT environment is when you're dealing with the mapping, when you create these groups, dependency mapping is a challenge and also key to making sure that you are aware of the outages and where those breaks are. So when you export these maps, you can actually create what we call dependency mappings. So I'm going to go ahead and create a different map this time with just switches to, but this time I'm going to go ahead and create dependencies so that I know that if anything was ever go down on a production line, I know where the break is because I know the dependencies of these devices and how the workflow gets to the end station. So I simply do that with the ping. You'll see here that I'm just going to go ahead and create a new group, and there's sensors, and then jump back over here to PRTG. And just like that, I've got another group. And if I look here at the dependencies, you'll see a tree of all the dependencies that we're having a hard time scrolling. You can see how we've mapped all the dependencies of those devices. So that if anything in that production line was to go down, you'll actually get a real-time notification of where that break is. and then you can start your troubleshooting from there. That process sometimes can be very tedious and difficult, but with the topology information that we provide, we can automatically do that and maintain that for the PRTG environment. I think lastly here, I wanted to also articulate on the configuration side. Not only do we provide the configuration backups, but we also provide the ability to create what we call scheduled tasks. UVexplorer can be scripted in a way that you can identify a large set of devices, any type, from your discovered devices. You can identify which devices you want a script to run on, and you can go in and define what you want to do on that device. You can see here that we have a script that says, I want to just log in, enable, and then run a few commands. These commands can range from anywhere from capturing data, but also changing the configuration of the device or uploading configuration snippets to your particular IT or OT devices. So the agent can both pull and push configurations to your IT environment and do it on a multi-device scenario, so that you can schedule, maybe at night you want to go ahead and change SNMP passwords, or you want to change device passwords. You can go ahead and schedule those for change on a particular schedule at a certain day and time. You can write a script that will automatically do that, so that you can automate the maintenance of those devices and kind of streamline how you interact with the configurations of your IT infrastructure. I know that's kind of a quick and high-level view of everything that we can do. Obviously, the goal here is to bring everything that is critical to an IT environment, both device discovery, asset management, and topology, along with configuration, and merge that into the monitoring infrastructure, so that you get one comprehensive view of everything that's running on your network. As you can see here, these maps are already showing the monitoring status here that PRTG is providing on the UVexplorer maps. Once you have that, then you can step back to your UVexplorer and set up your scheduled discoveries, so that you can run your discoveries on a particular schedule, and then also export those results directly to PRTG, so as to synchronize all the information that you are seeing here with your UVexplorer agent. So I know we wanted to leave some time for question and answer, so I'm going to go ahead and stop my presentation to this time and hand it back to David. But we can, if there's questions, we can go back to that at the end.
Thanks, Brian. So I am going to elaborate on the PRTG side. I believe you can see the screen there, right? So as you've seen, we can use UV networks as one of the polling agents that will provide us with information from the network, and also the dependencies and the creation of the maps and getting access to more information from the devices, right? So what happens next? What happens once you have all this information already mapped out by UV networks? Well, PRTG is, as I said before, a remote monitoring solution that has the purpose of supporting remotely monitoring the conditions of your devices connected to networks. This could be IT networks, OT networks, can be IoT devices, IIoT devices connected to 0G or to Bluetooth, sending information to a certain gateway, because in the end, our platform is multi-protocol, right? So we can deal with stuff like SNMP or WMI or SSH, right, for the IT portion, but we can also deal with other protocols like Modbus or OPC UA or MQTT, right? And we can also integrate with a bunch of other gateways that can support in the translation of different protocols into one of the protocols that we can natively support. So as you can see here, what we have is different, locations. We have a local probe, we have couple of remote locations. And for the sake of this demo, we have a bunch of different groups here that allows us to show what kind of things can be monitored with PRTG. So we might be looking at medical devices. We might be looking at servers, both virtual or physical, right? We might be looking at certain operating system aspects. This could be WMI, this could be different distributions of Linux, storages, the networking part that I'm going to open, look into more detail, everything related to critical power as well. So battery banks, you might be looking at UPSs or PDUs or, RPPs, or everything which is actually supporting the critical power in your facility. Then we have environmental conditions as well. So connecting to sensors, providing with temperatures, humidities, all these kind of things, vibrations as well. The security portion is related more to cameras and access controls, right, which are also relevant for factories. Then we have some cloud services, IoT things, printers, as Brian also showed, critical applications running, corporate websites, right? So the idea is to show that there is a lot of things that you can actually monitor with PRTG. And I'm going to go ahead and just click on the OT switches group that I have here, because as we mentioned before, you have a bunch of different vendors, right, which are not necessarily the Cisco's or, like the HPEs that you are finding in IT. Here we might be looking at stuff from Rockwell Automation. So here we have a Stratix 5700, right? And the kind of things that we can see in this kind of switches are not only related to traffic, right? Because of course, traffic is going to be very important. You want to be looking at your uplinks. You want to see whenever you have a bottleneck in one of your interfaces, and you will be able to look at all that information historically, because this is something very important. It's one of the main features that PRTG has. You will be able to export the data or keep the data in our database for a year as a default, but you can even extend that, right? So you can make it 2-3 years so that you can get long time data in order for you to then analyze it later on. You are going to see stuff like, hey, traffic total, traffic in, traffic out. You can see what's the information looking like for the last 2 days, 30 days. This is a very bad example because it doesn't have a lot of information, but you can see what I'm saying, right? So 365 days. And from there, you will be able to look at, okay, historic data. You can go to the detailed view of saying, like, I wanted to start on this day at a certain time, hour, and minute, right? To go to another date, time, hour, and minute, right? So you can export this information using XML or CSV in case you want to use this for further reporting or doing something different, right? And as you can see here, we are compatible with, in this case, it is mainly SNMP, which these OT switches are creating or are using, right? So Hirschmann is providing with similar visibility. We can see, system uptime, and you can see traffic, etc. But something I forgot to mention is if the device is compatible with providing with specific aspects on the health of the device, like it could be the power supplies or memory or CPU usage or fans or temperatures, you can also bring that information into PRTG and get alerted whenever there is any problem with any of the physical layer of your switch. You can look at other kinds of data like Armon, if the switch is compatible with that, so that you can see what kind of packets are going through that traffic. So it's not only about volumes, it's also what is it, right? And if the switches are compatible with other stuff, like could be NetFlow, for instance, then in the same tool, you can also get access to see what are the connections looking like for that traffic, right? So you can check and click on top connections. And from here, you will see source IPs, source ports, destination IPs and destination ports and protocols, etc. Right? So how much traffic is created by each of these connections so that you can keep an eye on who is using the majority of the traffic that you are getting in those switches, right? I'm going to go back here and you will see some other very well-known brands that we have been able to be compatible with. So maybe Moxa, Siemens, Phoenix Contact switches, right? Cisco switches, in this case, industrial Ethernet switches, for instance. And the kind of idea here is you will be able to get information on what is the traffic looking like. You can also see something which is interesting, which is the anomaly detection. So our tool is going to be looking at the baseline of traffic that your OT network's using. And whenever there is any kind of unusual behavior, which could be there is too much traffic or too few traffic, right, for a certain day in the week, we are automatically going to notify you about that. So without you needing to set up any thresholds or anything, or even reaching the thresholds that you probably got already there, you will be able to see any anomalies going on in your traffic. And the same happens for maybe servers that you have connected running applications critical to your production process. So we will be able to tell you, hey, the CPU is too unusually low or unusually high for this weekday at this time, right? So this is important because it can provide you with visibility of a certain problem that you might be encountering without you even knowing about that, right? Some other stuff which is important is this is not over when you get to the switches, right? There is another or multiple different layers below the switches, which could be, you know, IPCs. So if we are moving into the control layer, you probably will be looking at, you know, IPCs which are controlling certain processes in your production line. So you also want to make sure that you have available memory, available CPU for these processes to occur, right? You probably would be looking at maybe gathering information directly from the PLCs. And for this, if the PLCs are compatible with either Modbus or OPC UA, we will be able to connect to those specifically. In other cases, we probably would be able to connect using third-party tools like, you know, protocol conversion into OPC UA or protocol conversion into Modbus. And from here, you will also get access to see what is going on in this case with a Cymatic S7 PLC here, so that you don't only get to the point where you see what's going on in the traffic and the switches, but you can go a layer below that and see more, right? Other stuff that is very important that you can see here is, okay, you have certain temperatures, you probably have a certain, you know, counter in the production line. You want to know whenever things are not working the way they should, right? So as you can see, temperature in this case can have different thresholds. So it can be bad that it is too low, it can be bad that it is too high. So changing these thresholds is very simple. You can do that by enabling alerting based on limits, right? You can create your own thresholds and then leave PRTG working for you in the background. Once you have that working for you, what you can create are different rules, and these rules will allow you to see, you know, how do you want to handle those notifications. So if a sensor, in this case, any metric, any signal that you are gathering from your devices is in a certain state, which could be error state or warning state or unusual, you can set up for how long does it need to prevail that situation before you are alerted using one of the different methods that we have for that. And in this case, it's important, as Paul mentioned before, or sorry, Brian mentioned before, we have different ways to alert for conditions which are out of what's normal, right? So you have email, you have SMS compatibility with different providers for SMS. You can execute actions or execute programs as well. So this couple of notifications will actually allow you to take control and support in remediation of any problem that you probably have. You can do some other IT stuff here, but you can send push notifications to your cell phone or to somebody's cell phone. You can also use either Teams or Slack in order to create groups of people which might be able to support in solving the issue that you are having, right? And there are this couple of notifications here as well in case you are using either MQTT or OPC UA. Now, the OPC UA notification is important because, as I mentioned in the beginning, there is a lot of, nowadays at least, you can see an increasing number of SCADA systems which are compatible with OPC UA, because OPC UA is trying to get, you know, recognized as a standard for manufacturing and industrial or industry 4.0. So what happens is you can actually support the visibility of possible problems that you're having in the networking layer for your production teams by creating OPC UA notifications that will send a notification that can then pop up in the SCADA system or in an HMI, which are compatible with OPC UA, telling people in the shop floor, hey, you probably are running on a failover of the switch which supports this machine that you are manipulating at this point, right? So you can provide information on anything that you have in your, say, more IT kind of monitoring into the production tools for making sure that things are going well, supervision tools like SCADA systems, right? So this is very important. And we are moving a step forward in this case because we are creating our own OPC UA server that will allow you to extract information from PRTG, take it to another OPC UA server. So again, let's think about a SCADA system. And that SCADA system wants to be, or the people looking at the SCADA system, they want to know what's going on with a certain, critical application that's running in that shop floor. They don't have access to any of that, but now they will be able to do that on demand, not only whenever there is a wrong condition, right? So all these alerts are very important because they can support in bringing information from IT into your OT tools as well, in case you have them. And if you don't, we do provide with data visualization, right? So here there's an example of how could it look like to have access to see, what's the current state of an OT switch, different database servers, perhaps different workstations which are in the shop floor, maybe some HMIs as well, and different PLCs connected to it. So in this case, we are reporting on status, we are reporting on traffic, we are reporting on whatever is important for you and for the people looking at the specific dashboard. Could look like this as well, right? So different ways of visualization in the end. So here we have a diagram of a certain production line, and this production line will have information from whatever you are monitoring on top of it. So it could have information on, production units or defective units versus good quality units and things like this. So what we're struggling to or trying to get is full visibility between IT and OT. So from the lowest level of the sensors and the actuators through the use of Modbus OPC UA and these converters that can give us information from, say, Profinet or Ethernet IP into OPC UA, we are able to provide information on the robotic arms and pretty much anything that's connected on the lower level. And then we are also able to provide with information on the control layer, as we see. You can also monitor your visualization layer for OT, right? So if you have orchestrators, if you have SCADA systems, if you have HMIs, you can also see what's going on with them, and then go all the way to your manufacturing execution system and your ERP as well, right? So in this case, we have some SAP sensors here. So the idea is you can get access to see not only what are the conditions in all the layers, but also extract information if needed. If you need to eventually have information on temperatures and your cooling system or an overview similar to this for your data center in the shop floor, you can do that. And if that doesn't work out for you, I mean, in this case, you have power, and then you have all the operations for different devices connected to it. But if that doesn't work out for you, it doesn't matter, because you have the possibility to create other visualizations like this, right? Where you can see what's going on from, a very simple way, even though not necessarily getting to the details of, the traffics, etc. So here you might be looking at the different errors and problems that you have here, right? And you might be looking at, okay, I have a certain water pressure, which is 126 PSI, right? This is above what I should have. So the idea is you can jump from the visualization in case you don't have a SCADA system. We can provide you with visualization of the data that your environment is creating, right? And this is very important because, again, just think about the possibility of using this tool to get, access to just store this data for a long period of time without being charged for that. That is very important, because then you can use that data for further process later on, right? So the last things I want to show before we go for Q&A are a couple of resources that I can encourage you to look at. Some of them are the success stories from customers. I mean, you have customers from all over the world. We have some from the US, we have some from Latin America, we have many from Europe, of course, right? Some big names are there which are using our tool, like Rexroth from Bosch or Siemens, for instance. And the other thing is, there is a video here of how important it is not to only take care about the network, but everything which is connected to it, right? In this case, a server running a critical application on a mining site for loading trucks was having a trouble, and they were able to figure it out by actually monitoring that, which was completely out of the scope of IT because they were not part of this kind of, production process. So with that being said, I will stop sharing my screen now again, and we are going to go for the Q&A session. And I saw that we already had some questions, but let's see what we get. Well, in the meantime, I'm going to get this here because then you can get access to Paul's or my email address in case you want to get more information afterwards. But we had some questions here about, you actually, Paul, you have already answered several questions.
There's quite a few good ones there, yeah.
Yeah, you want to rate them?
Sure. I think one of the ones that were most important as far as setup and those attending this webinar was from an anonymous attendee, but what is the typical deployment effort to configure application and various network devices on the network to report back? So pretty much how long would it take to set up UVexplorer and PRTG on an environment and get it up and running? It's a good question. I think on our side, it really depends on how big your network is, what you're trying to do. For UVexplorer, we can have that up and running probably in 7 to 10 minutes and discovering, looking for different devices, what we can find. At that point, it's troubleshooting. It's exploring parts of your network that have protocols or don't. Some of your devices may not be set up correctly. We have to troubleshoot that. As far as the PRTG side, I think, David, you can speak to that.
Yeah, I mean, having, again, the basic configuration can take less than maybe 30 minutes. And then it's a matter of creating, the proper things, right? So how do you want to deal with notifications? How do you want to deal with, overall dashboards, etc.? But it shouldn't be an effort of maybe more than 2 weeks to get everything, in place the way you need it. We have some other questions here. How did the business process sensor figure in PRTG as shown in the demo? I believe this is separately configured in PRTG. The business process sensor actually is a way in which you can bring information from multiple sensors that you have set up independently, right? So the idea is whenever you're looking at a full service that you're providing in your environment, you want to, let's say, you want to see a specific production line which has a bunch of different PLCs, and perhaps it has, information from the sensors and the actuators that you have there, but all together you are looking at a single thing. So in that case, what you do is you just bring information from the multiple individual sensors. You set up a hierarchy for them. You set up a certain weight for them, so you can tell if, I don't know, 50% of these sensors are running, then my service is running correctly and it's not going to be stopped. But if I have 51% of them not working, then I'm in trouble because I won't be able to provide or deliver the service that I have. So Shankar, if you want to learn more about the business process sensors, I'm definitely going to send you some literature about it. You can see some, you will be able to watch some videos also on YouTube on how to set them up, right? And if you still have any questions, just let me know and we can get over that. And I see that there are at least another 7 questions, right? But I guess given the time, probably we won't be able to answer them all here. I mean, Brian has already answered several of them. But what I could encourage you is if you want to, get access to more information, either about UVexplorer or PRTG, what you can see are our email addresses here on screen, right? And just send us a note. We'll be glad to reach out to you, maybe set up a meeting or whatever is needed, so that you can get access to know more about both tools, either separately or working together, right? And in any case, we are going to get access to all your questions, and any missing answer will be sent out by email. Sounds good? Okay, so I guess we can wrap it up then.
Yeah,
Well, Brian.
It's great.
Yeah.
Thank you, David, for having us join. It was a pleasure to talk with PRTG. PRTG's, we've been integrated with you guys for 6 years, and you guys are one of our best partners. We appreciate the chance to join and co-host with you on this and talk about OT networks. And we're looking forward to the conversations that this sparks with our viewers and also the rest of the network out there that's having issues here in OT. We're here to kind of help with that and help these companies kind of address these new issues that are popping up.
Awesome. Thank you very much, Paul and Brian, for the presentations. Likewise, we really enjoy working with you guys, and we really appreciate everybody's time today to join this webinar and learn a little bit more about how can we support you in your daily efforts with OT networks. So have a very nice day, everybody, and see you next time.